Hello everyone, welcome to Mudgal Education, and I hope everybody is doing very well, guys. And as you all know, this is my new initiative for all the electrical and ECE students to get a good knowledge for their particular examination, whatever examination you are giving, like for a GATE, ECE, AJE. So we are discussing a few topics in a network theory. In the previous two classes, we have discussed about the network reduction techniques. We have discussed about series and parallel circuits, and also we have discussed about the symmetrical concept. If you haven't watched those videos, I will advise you to watch those videos on my channel and also subscribe to my channel so that whatever the content will come, you can watch that particular content also. Okay, it's going to be very helpful for your upcoming examination. And guys, soon my app is going to be launched, so you can also download that particular app, and you can also avail the paid courses. And to contact me directly, you can join my Telegram channel that is given in the description of this video. Okay, so we can start our topic now. Today's topic is going to be about a KCL and KVL, and yes guys, you have to believe it, this topic is actually a base for your entire electrical and electronics engineering. Whatever subject you are studying, like power electronics, power system, analog, let's talk about EDC, talk about the semiconductors, whatever the subject you are reading or you are learning, you have to use the KCL and KVL. And it also it's very important to have a proper understanding of this concept. So yes, we are going to study this concept. So first I will tell you all about the KCL KVL, including the points in which we will discuss where you cannot use these particular laws. Okay, KCL and KVL are the laws which are useful for many circuits, but not every circuit. So that we are also going to discuss. Okay, so let's start our class. Let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. Amateur gold medalist from NIT Allahabad, 8 times GATE qualified, and these are my area of expertise. Now, before learning the KCL KVL, you need to understand the meaning of nodes, branches, and loops. Okay. Now, if you talk about a branch, a simple definition of branch is the branch represent a single element connected in a network that is known as a branch. Okay, a branch can be a voltage source, it can be a current source, it can be a resistor, inductor, capacitor, or any other element. Whatever the elements are connected in a network, that will constitute a branch. That is a simple definition of a branch. Now, if you talk about if you go further, then branch again can be divided into two parts. One is a simple branch, and another one is a principal branch. Now, what is the meaning of simple branch? Simple branches are those branches which contain only one element, whereas principal branches which contain number of elements, through which the current remain constant, or you can say current is constant, or you can say principal branches are those branches which are connected in series. For example, if you observe this circuit, you can let me draw a circuit here. I guess the circuit is hidden, so let me draw the circuit again. So if you observe this circuit carefully, if I ask you how many branches it has, then you can easily tell me that sir, the number of branches here is 4, because the number of branches here is 4, because here you can say that sir, because of 4 elements are connected, and that is absolutely correct. Now what I will do, I'm going to add one more element here. I'm going to add one more element here. Let me draw the second circuit. Let's suppose I'm going to draw this particular circuit. Okay, earlier it was a 4 branches. Now here for this particular element, you can say this particular network, you can say sir, it has 5 branches. That is absolutely correct. If you are saying that it has 5 branches, that is absolutely correct. But if you divide these 2 branches according to a simple and principal node, what you will say, sir, how many simple branches here? We have 3 simple branches, and we can say 2 we have a principal branch, or you can say, and there's one more point. There is one more point. These two branch can constitute the current flowing through these two branches are same. These two branches are same, so we are going to count it as a one branch. Now we are going to count it as a one branch. Now why it is important? It is important because after a few minutes I will tell you one particular formula of one particular universal formula of branches and nodes and the loop. In that particular formula, you need to understand when you calculate the number of branches, you have to take those branches as a single branch in which the current is constant, or those elements which are connected in series. Okay, so these are not all about branches. Now let's talk about node. What do you mean by a node? A node is a point of connection between two or more branches. Now again, a node can be divided into two parts. And again, a node can be divided into two parts. How? Let me tell you. Again, a node can be divided into two parts. So we have a simple node, we have a simple node, and we have a principal node. We have a principal node, also known as the junction. Also known as the junction. Now in this year GATE examination electrical, one question has been asked over how many junctions are present in a network. Okay, so junctions are also important. So what is meaning the meaning of simple node? Simple node means where two branches meet. Simple node means where two branches meet. Now what is principal node? Where three or more branches meet. Where three or more branches meet. So basically, if I again draw the diagram, if I ask you how many nodes are present here, R1, R2, R3, and this is a voltage V. Okay, so here we can observe clearly. If I want to identify how many nodes are present here, we can observe clearly these four branches are connected together. So one is this node and the second one is this node. If I ask you how many nodes are present in this circuit, so these are the two nodes, right? Now all these two nodes are actually a principal node because here three or more branches are meeting. Now in the same way, the question has been asked in your GATE examination, in which they have asked how many junctions are present. So it was very simple. You just have to count the nodes which has three or more branches. Then you can say, okay, these amount of junctions are present here. Okay, now let me draw one more circuit. Now if I ask you how many nodes are present here, then what will be the answer? You can pause the video and think about it. Let me tell you. So see very carefully. We have this node. Why? Because R and V are actually connected to each other. Then we have this node. Then we have this node. So if I ask you how many nodes are present here, then we have three nodes. But out of three nodes, this is simple node because two branches are meeting. So this is a simple node, whereas these two are the principal node. I will tell you why we are classifying in different type of nodes and branches because of the formula that we are going to use. But meanwhile, don't worry about it. Just be patient for few minutes and then you will going to understand this concept thoroughly. So in this way you can identify the simple node and a principal node, and also between the branches. Now next is a loop. Now if we talk about a loop here, okay, understand the formula. If you talk about a loop, what is loop? Loop is simple. What is loop? The definition is already given. If you talk about a loop is any closed path in a circuit. Simple सी बात है. A loop is any closed path in a circuit. If a loop is any closed path in a circuit, then I can again divide it into two parts. One is mesh and another one is, I will say, there's not any other name. I can say non-mesh. Okay, there's not any simplified name. You can say non-mesh. Now what is the meaning of mesh here? What is the meaning of mesh? A very important. The meaning of mesh is the loop which do not contain Loop does not contain any other loop. Does not contain any other loop is known as a mesh. And here non-mesh is loop which contains other loop. Which contains other loop are known as non-mesh. Okay, other loops are known as non-mesh. Okay, let me give you an example here. Let me give you one simple example here. If you observe this circuit, okay, let's observe this circuit very carefully. If you observe this circuit, this is V, this is R1, this is R2, this is R3, this is R4. Now, if I ask you how many loops are present here, if I ask you how many loops are present here, you will say, ki sir, this is one loop, okay, fine. Sir, this is second loop, also fine. You will also say, sir, this is the third loop, which is also fine. So how many loops are present here? We have 3 loops present. But out of these 3 loops, if you see very carefully, L1 and L2 are meshes. L1 and L2 are meshes. Why these two are meshes? Because if you observe carefully, there is no loop inside L1. There is no loop inside L2. But if you observe the L3, L3 is non-mesh. Why? Because inside the L3 you can have 2 loops, L1 and L2. So L3 is not a mesh. Okay, so identification of meshes are very, very important. I hope you understand this concept, right? Now wait a sec. Okay, understand this concept? Yes or no? Okay, now let's talk about the formula. Let's talk about the universal formula. This is actually a universal formula we have. This is actually a universal formula we have. Let me tell you. Now let me discuss this formula separately. Okay, wait a sec. This is what? Okay, so we have a universal formula that number of branches is equal to loop plus node minus 1. Number of branches is equal to loop plus node minus 1. Now, to use this formula, there are many ways to use this formula. I am telling you one of the way to use this formula. The first way to use this, what is B here? B here. B represent branches. V represent branches. L represent loop and N represent nodes. Now any circuit will follow this particular formula. I am talking about circuit. Circuit means in which there is a closed path and current can be flow. Network is different. Network can be a open network, network can be a closed network, but a circuit is a network in which a particular current can flow. Okay, so in every circuit this particular formula will be applicable. For example, let me draw one circuit here. Okay, let me draw one circuit here and let me check whether this formula is applicable or not. Now if you observe this particular circuit, how many branches are there? Branches represent an element in a circuit. So we have 1 2 3 4. We have 4 branches here. How many nodes or I will say how many loops are there? Let me check here. Wait a sec. If I say how many nodes are present here, so this is one single node, this is a second single node. Now you will say, sir, can we take a simple node also? No, we cannot take a simple node while calculating, while using this formula. While using this formula, you cannot take a simple node, you have to take a principal node only. So if you take a principal node, or you can say junction, so how many nodes are present here? We have 2 nodes are present here. Obviously, any doubt here? We have 2 nodes which are present here. Now we can calculate the number of loop. How? Or you can say, or you can also check number of branches is 4, the loop and 2 minus 1, so loop comes out to be 3. If you check it carefully, the loop comes out to be 3. Now you can also check here, this is one loop L1, this is second loop L2, and this is third loop L3. Simple. So number of loops comes out to be 3. It means the formula is satisfied here. Now one more thing you need to understand here, bacho, that here the node we are taking is actually a principal node, or you can say a junction. You cannot take a simple node in this calculation or while using this formula, okay, while using this formula. Now second way in which you have to use this formula, This is the one way to use the formula. The second way, and this way you have to use. Now in this way, when you are calculating a branches, you need to make sure one thing. That you are only take those branches which when you are calculating branches, you can do one thing. First point, combine branches which are in series. Combine the branches which are in series. And then count all branches. What is the meaning of this line? So listen very carefully. So here you can see in the above network, this voltage source and R1 are in series. So these two branches are in series. So I will count them as one branch. This R3 I can count them as a second branch, and this R2 I can count them as a three branch. So according to this funda, we have a three branches. Again, nodes are the principal node, we have two. Now calculate the number of loops here. You will get the number of loops are 2. Now these are actually meshes. So when you are going to combine the branches which are connected in series, then what answer you get? The loop you get are actually the meshes. So there are two ways to use this formula. Either use the first way, in which you are calculating all the branches or counting all the branches, or in the second way, where you are combining those branches through which the current is same, or I can say they are connected in series. So you can and also by using this particular funda, the loop here are actually the meshes. Okay, now why this formula is important? Because when you see the graph theory chapter, you will need to understand there are different type of terms comes out, like cut set matrix, tie set matrix. So in these cases, this formula is going to be help you a lot. So further, I am going to use this formula in this way only, where I'm going to combine the branches which are in series, and the number of loop are actually telling us the number of meshes. Okay, so this is going to be useful, and this we are going to use in your whole concept also in the last chapter. Now let's go to the next topic, which is a KCL. Now what happened earlier the Ohm's law was given. Okay, the Ohm's law is given. Now if you talk about the Ohm's law, it is simple. The law that voltage is directly proportional to the current passed through it at a constant temperature. Now Ohm's law is applicable for a linear circuit. The main point is Ohm's law is applicable for a linear circuit, but it is not applicable for a non-linear circuit. Okay. Next point, Ohm's law is only for the condition that the temperature remain constant. If the temperature changes, then the Ohm's law is not applicable, right? Now apart from Ohm's law, there was a scientist known as a Kirchhoff who has given two laws. One is KCL and another one is KVL. Now KCL, simple, everybody knows this law. The KCL means if you have a node, or I can say a junction, or you can also use it on a simple node, that's totally up to you. So for any node, you can see the number of branches are connected to it, so there will be a current flowing through those branches. So the simple definition of KCL is sum of the current entering a node is equal to the sum of the current leaving the node. Sum of current entering the node is equal to the sum of current leaving the node. For example, in this circuit here you can see I2 and I1 are entering and I3 and I4 are leaving. So can I say sum of current entering? It means I1 plus I2, and the sum of current leaving, which is I3 plus I4. So simple, I can say the KCL for this particular junction is this: I1 plus I2 is equal to I3 plus I4. Now one more point about KCL, that it follows the law of conservation of charge, which is a universal law. So that is very important. And the next point to understand about KCL, that it is applicable for non-linear circuits also. It is important. It is applicable for non-linear circuit also. It is applicable for non-linear circuit also. And one more point. It is not applicable, which is important, it is not applicable for distributed network. It is not applicable for a distributed network. Now let's talk about the KVL. KVL. In a KVL, the definition is simple. The voltage drop across the loop is 0. So if we have a loop here, as you can see in this diagram, if I add all the voltage drops here, the particular addition gives us the answer 0. The sum of voltage drop, or you can also say the sum of voltage drop is equal to the voltage rise, or I can say the sum of voltages is 0. The algebraic sum of a voltage around a closed path or a loop is 0. Again, the same as KCL, it is applicable for non-linear circuit. It is applicable for non-linear circuit. Next point. It is not applicable for distributed network. For a distributed network. Okay. Now, what is the meaning of distributed network? Simple. See, for example, this is my wire. This pan is my wire. For example, this pan is my wire. Now, when we do the theory or when we solve the numericals, what we assume that the whole resistance, inductance or capacitance are constituted in one place. We generally draw a resistance like this. That for the entire wire, the resistance is constituted at one place. But what actually happened? The whole wire is made up of resistor. The whole wire is made up of resistor like this. For example, if this pan is my wire, then whole resistance will be on its surface. The resistance are basic. The resistance is basically distributed throughout its surface. It's nothing like that. The resistance is concentrated in one place. It is actually a distributed. So when you have when you are going to take a practical case in which you have a distributed elements, then KCL and KVL are not applicable. 1 point. Second. Now, how to apply the KVL? Because most of the students will say that have problem in applying KVL. So let me draw one particular circuit. And I will explain you how to apply the KVL. Now, when you apply the KVL, you need to understand one thing, that you have to show the direction of current. Now, it's totally up to you what direction of current you show, or if it is given in a question, no need to change the direction. So if it is not given in a question, that's totally up to you what direction you can show. But if you think logically here, the current will flow in this direction only. The current will flow in this direction only. Now, if the current is going to flow in this direction, now you have to apply the polarity. Now, always remember, across resistor, current enters to the positive polarity and leaves the negative polarity. For this resistor, positive, negative, positive, negative. Always. For a resistor, current enters the negative polarity and leaves the positive polarity. Now, if I say the voltage across here is V1, the voltage across here is V2, the voltage across here is V3. Can you calculate the voltage? Yes. Using the Ohm's law, you can calculate IR1. V2 is actually IR2 and V3 is actually IR3 using the Ohm's law. Now, how to apply the KVL? There are two methods. There are two methods that I am going to tell you. Method 1. You just move in a direction of current, and whatever sign you can see first, you can put that sign there. For example, I'm going to move in this direction, okay, in this direction, because, or I can say the clockwise direction. So I can see there is a negative sign here, so it will be minus V. Now moving further, there is a positive sign here, so I will say plus V1. Moving further, there is a positive sign, I will say plus V2. Moving further, there is a positive sign, plus V3 equal to 0. So there's a first method you can use here. What is the method 2? In a method 2, you need to understand, when you are going from positive to negative, so what is happening? Positive to negative, you have to use the sign minus, because there is a voltage drop. And when you are going from negative to positive, there will be a plus sign, because you are using a voltage rise. So again, I am going in a direction of current. Across the voltage source, I can say I am going from minus to plus, right? So there is a voltage rise, so I will say plus V. Now again, across R1, I am going from plus to minus. It means the voltage drop. So I will use minus V1. Across R2, again voltage drop. Across R3, again voltage drop. So this is the second method to write down the KVL, and you can see from the method 1 or a method 2, you are going to get the same answer. Okay, just the sign of each term has been changed. So I will advise you guys in a comment section, tell me which method you use. I'm going to use the method 1 because I have a practice in a method 1, but if you have a practice in method 2, you can use the method 2 also. Okay, no worries about that. You no need to change the method. Just whichever method you are using, you should have a good amount of practice in there. You should have a good amount of practice in there. Okay, understood? Now also guys, subscribe to my channel and share the channel among your friends so that more and more students can join the session and watch this particular class. Okay, I can see the subscriber is very low since although I am continuously uploading the video, you are watching my classes but don't subscribe it. So I'm kindly requesting you to subscribe it. Now let's discuss the question one by one. Now before discussing question, I will tell you there is a limitation of KVL also. According to a circuit, there will be a limitation of KVL also, but that I will discuss through the questions only. Okay. Now let's suppose this question. Question is find a branch current I1, I2, I3. Achha, don't worry about a mesh analysis here. We are not discussing a mesh analysis right now. Let me just delete it. We have to find out the current I1, I2 and I3 here. Simple. This is a question. I need to find out a current I1, I2 and I3 here. Also, they have given a direction of currents. Okay. Now, you can see, since the current I1 is given, I can mark the polarity according to that. Since the current I1 is given, I can mark the polarity according to that. See very carefully. This, let me skip this question first. When I will explain the mesh analysis, then I will explain this question. We will do this question right now. We will do this question first. Okay, when I will explain the mesh analysis, I will solve that question. So here the question is find the voltage V0 and the current I0 in the circuit shown in a figure. So this question you can see on board. First of all, here you can see this is the dependent source. Now if those students who don't know about a dependent source, let me tell you, there are 4 dependent sources we have. We have voltage control voltage source, voltage control current source, current control voltage source, and current control current source. So basically we have 4 dependent sources here. Now how to identify which source we have? First of all, you have to see what is given inside a dependent source. A dependent source always represent like a diamond shape. If inside there is an arrow, it means it is a current source. If inside there is a polarity, it means it is a voltage source. Okay. Now you have to check the dependency. So if the magnitude of this given in terms of current, then it will be a current control. And if a magnitude is given in terms of voltage, then it will be a voltage control. Okay. Similarly, suppose this is a current source, right? Now the magnitude here depends on voltage, so it becomes voltage control voltage source. Okay. Now understand next point very carefully. If it is a current source, then the magnitude, whatever the dependency here, above the dependency is on current, below the dependency is on voltage. Whatever the dependency here, both magnitude represents a current. Because it is a current source. You don't need to see the dependency to identify whether it is giving a current or a voltage. For that, you have to see inside the diamond shape. If you have an arrow sign, it means you have a current source. So whatever the dependency there, the magnitude actually giving you the current. For example, in this question, we have a current source. I can identify it is a current source and it is actually current control current source. So the magnitude here is 0.5 I0. It is actually the current given by this source. So here you can see 0.5 I0 is coming to node A. From here I0 and from here the 3 ampere is entering. So I can apply the KCL. What is KCL? Sum of current entering. So I can say 0.5 I0 and the 3 ampere are entering equal to sum of current leaving. Now which currents are leaving here? Only one current is leaving and that is only I0. So I0 is leaving. So I can solve this equation. To find out I0. Then I0 comes out to be 6 ampere. Now in the question you need to find out V0 also. So here you can see I0 is going towards 4 ohm and according to that the polarity is plus minus, which is already given. So I can say what is V0 using the Ohm's law, 4 multiplied by 6, 24 volt. Using the Ohm's law we can say 24 volt, right? Next question. For the circuit shown figure, find the voltage V1 and V2. Now see very carefully, see very carefully. In this particular question, I can say direction of current is like this, direction of current is like this, because it's a common sense, the current flowing from positive polarity of a battery to a negative polarity of a battery. Now because of this direction of current, the polarity across 2 ohm should be this and the polarity across 3 ohm should be this. Now the point is, they are asking V1 with the same polarity, that is because of a current, but for the V2 the polarity has been reversed. So since the polarity has been reversed, the V2 comes out in a negative. Okay, that's the important point you need to understand. If the polarity that is given in a question and the polarity that you are assuming, if both are different, then you have to put the minus sign, and if both are same, then there's no need to put the minus sign. Here you can see I can find out a current easily. The current is 20 divided by 2 plus 3, it comes out to be 4 ampere. Voltage divided by the total resistance, what is V1? V1 is 2 multiplied by I, it means 8 volt, but the V2 I have to use the minus sign. 3 multiplied by I, it is minus 12 volt. Okay, why the minus sign? Because the polarity is different, polarity is opposite. Next, in the circuit, R1 is 2 ohm, R2 is 3 ohm, R3 is 6 ohm. Obtain the equivalent resistance. Simple hai. Equivalent resistance you can calculate. 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now what is 1 upon R1? It is 1 by 2 plus 1 by 3 plus 1 by 6. If I take the LCM, it comes out to be 3 plus 2 plus 1. It comes out to be 1. So I can say R equivalent is 1 ohm. Simple. Now they are asking current in each branch. So I guess the voltage is not given. There is a misprinting here. I will say voltage here is 18 volt. So if the voltage here is 18 volt, I can find out a current in each branch. Simple. Why? Because all the branches are parallel to a voltage source. So simple, I1 is 18 divided by R1, so it is 9 ampere. I2 is 18 divided by R2, so it is 6 ampere. I3 is 18 divided by R3, it is 3 ampere. Simple, right? Next, find the value of a current I in the circuit of a given figure. Find the value of a current I. Okay, simple. How? You have to reduce this network into a simple form. 3 15 ohm resistor are connected in parallel, so they will give you the 5 ohm. Whereas 20 parallel to 5 will give you how much? 20 multiplied by 5 divided by 20 plus 5, so it comes out to be 4 ohm. Similarly, 24 parallel to 8 will give you how much? 24 multiplied by 8 divided by 24 plus 8, so it is 32, so it comes out to be 6 ohm. Simple. Now all the resistors are in series, so I can say what is R equivalent? We have 12 ohm, then we have 4 ohm, then we have a 5, and then we have a 6. So how much it can get out? 32 ohms. 16, 6, 22, 32 ohm. So what is the current I? It is equal to 80 divided by 32. Simple. So if you cancel by 8, so it comes out to be 16. 16 5 80, 16 to 32. So it comes out to be 2.5 ampere. It comes out to be 2.5 ampere. Simple. Next, it's a very good question. The question is, in the interconnection, let me reduce my size. Here you can see the question is, in the interconnection of ideal sources shown in a figure, it is shown that 60 volt source is absorbing power. Which of the following can be the value of current source I? Now this line is important. Which of the following can be a current source I? Now when you are using a word can be, maybe, these words are very important to take care. Can be means that you are not going to get the actual answer. You are not going to get an actual answer. You are going to get some range of answer, or there is some condition that you have to be take care. So since the word is using can be, it means we cannot find out the actual value of I. It may happen that we can find out a condition or a range, but not the actual value of I. Similarly, if the word maybe is using in a question, it means also you cannot find out the actual answer. So how to solve this question? Simple. Just you need to understand the basic carefully. So if you see very carefully, the current I is flowing in this direction, 12 ampere is leaving. So can I say how much current is flowing here? I will say 12 minus I is flowing in this direction, because current I is, sorry, my fault. If the current I is coming here and 12 ampere is leaving, so I minus 12 will be flow in this particular branch. So I can say I minus 12 is flowing in this particular branch. Now the same current is flowing in this direction. Now they are saying that 60 volt source is absorbing power. Now let's discuss about the case of a power. Let's discuss about case of power very carefully, very carefully. If you have any element, understand this scenario. If you have any element, if the current enters the positive terminal, that it means that the element is absorbing power. And you can say the power absorbed is equal to VI. Now if across any element current is leaving the positive terminal, it means the particular element is delivering the power. And the power delivered here is equal to V multiplied by I. So first of all, according to a polarity and a direction of current, you need to identify what is actually happening. Now, since we know that the conservation of energy principle, power can neither be created nor be destroyed, this particular phenomena we know about a power. So I can also say the same power in a negative sense has been delivered here, minus VI. Simple point. Power can neither be created nor be destroyed. So if you are absorbing the power, the same amount of power you are delivering in a negative sense. So here you can see here very carefully. If this is absorbing the power VI, then the power delivered will be minus VI. The same thing is happening here. If this element is delivering the power, then the same amount of power is absorbing here, which is minus VI. Simple sense. Now see this question carefully. According to a direction of current and a polarity, what is happening to a 60 volt? That it is delivering the power. Because the current is leaving the positive terminal. So I can say how much power is delivering? Voltage multiplied by the current, which is 60 multiplied by I minus 12. It is delivering the power. Okay. Now what is the power absorbed? Because in the question they are saying that it is absorbing the power. In the question it is saying it is absorbing the power. So power absorbed will be negative of power delivered. So I can say 60 12 minus I. I just change the sign there because of the minus sign. So I can say it is 60 12 minus I. Now understand this point. They are saying power is absorbing. They are saying power is absorbing. If they are saying power is absorbing, that power must be absorbed here. And how you will make sure that power is absorbed? That whatever the power absorbed you have, that should be more than 0. When the power absorbed is more than 0, then it is positive. Then you can say actually it is absorbing a power. Okay. So this will be 60 12 minus I. It is more than 0. I can say I less than 12. So for 60 volt source to absorb power, the I should be less than 12, and the only option which is satisfying here is option A. Okay, understand this phenomena very carefully. First, according to a direction of current, we find out the power delivered, but we need a power absorption because it is given in a question. So it is asking in a question actually. So power absorption is negative of power delivered. So we got 60 12 minus I. Now in the question it is clearly mentioned the 60 volt source have to absorb power. So for absorbing power, the particular power absorbed should be more than 0. Because if it comes out to be negative, then again you will say that it is opposite to that. Okay, the negative sign only tells you the opposite. For example, if you are calculating a direction of current and a negative sign comes out, it means direction of current is opposite. If you are calculating a voltage, negative sign comes out, it means the polarity of voltage is opposite. Okay, so this way the negative sign is very important. The next, find the Vx in this question. Simple. Find the Vx in this question. How we can solve this? Let's see. I'm assuming the current I is flowing. Because of that, the polarity is plus minus across 5 ohm, plus minus here also a plus minus. Now one thing I can say, I can apply the KVL. Now when I applying the KVL, I'm going in a clockwise direction. So I can say it is minus 15. It is plus I multiplied by 1. I applied the Ohm's law across here. Now this is a dependent voltage source. It is a voltage control voltage source. So since it is a voltage source, this is actually a voltage magnitude. So I can say it is plus 2 times of Vx, again plus 5 times of I plus 2 times of I equal to 0. So it is 5 plus 2 7. It comes out to be 2 Vx plus 8 times of I equal to 15. But the problem here is that I have a 2 variable in an equation. So when I have a 2 variable, I should have 2 equation also. So from where I can get a second equation, you can see clearly here, bache, that across 5 ohm the voltage is Vx. So can I say Vx is equal to 5 multiplied by I. This is the second equation. So let's put a volt value here. So 2 multiplied by 5 times of I plus 8I is equal to 15. So I can say how much the I here, 2 5 10 plus 8 18, 15 by 8. If you cancel by 3, it comes out to be 5 by 6. Now what is Vx? 5 multiplied by 5 by 6, it will be 25 by 6 volt. Okay. So if you think if you see any calculation mistake, you can mention in a comment section also. I will rectify that mistake also. But let me check. I guess there is no calculation mistake here. Let me check it again quickly. Yes, so there is no calculation mistake, but still, if you find any calculation mistake in any question, you can mention in a comment section. Now next, for a network shown in a figure, find the current, voltage and power associated with the 20 kilo ohm resistor. So they are saying you need to find out current, voltage and power associated with a 20 kilo ohm resistor. Let me show you. Let me just give me 1 sec. Just let me show you the complete question. So they are asking with a 20 kilo ohm resistor. So I hope you are able to see it with the 20 kilo ohm resistor. Okay. Now how you can solve this? Let's solve this question one by one. Here you can see 5 milliampere is a current flows through 10 kilo ohm, comes out from here. So I can calculate the V0. V0 is 5 milliampere multiply by the resistance 10 into 10 is to power 3. It comes out to be 50 volt. First point. Now second point you need to understand here, it is current control, it is voltage control current source. It is voltage control current source. So 0.01 V0 is actually a magnitude of a current. It is a magnitude of a current because the source is because it is a current source. So it is 0.01 multiplied by 50. So it comes out to be how much? It comes out to be 0.5. So the 0.5 ampere is going in this direction. I can find out a current I. I can use the current division rule. While using a current division rule, I can say the I is equal to 0.5 multiplied by the, I can say 0.5. It is actually a milliampere. Okay, why it is in a we are working in a milliampere. The current is in milliampere. Let me check one thing. They have not mentioned here. Actually, they have not mentioned here. The voltage comes out to be 50 volt. If the voltage comes out to be 50 volt and it is 0.01 V0. Let me tell you one thing here. We calculate 0.01 V0, it is 0.01 multiplied by 50. So it is 0.5, it is actually in ampere. It is actually in ampere. Okay, it is actually in ampere. Why? Because the voltage that we have calculated from the first loop, from this particular loop, the particular voltage is in volt. So now we have a 0.5 ampere current which is flowing. Okay, so 0.5 multiplied by 5 divided by 5 plus 20. Simple, we have applied the current division rule. So it comes out to be 5 by 25. It comes out to be 0.1 ampere. I am converting it into a milliampere. So it is 100 milliampere. I am converting into a milliampere. So it is 100 milliampere. Now what they are asking, find the current with the 20 kilo ohm resistor. Done. They are asking a voltage. Voltage is also simple. Voltage is current multiplied by the resistor. Now current is in milliampere, resistor is in ohms. So it is comes out to be 2000. Resistance is in kilo ohm. So it comes out to be 2000 volt. The voltage is 2000 volt. Now finally they are asking the power associated with it. Power is V multiplied by I. Now the voltage, again I can say the voltage is 2000. The current is actually in a milliampere, 10 is to power minus 3. So it comes out to be 200 watt. Okay. So you have to take care of the sign very carefully. You have to take care of the sign very carefully. Okay. Any doubt? If you have any doubt, again my Telegram channel is on. You can ask your doubts there, and also you can ask your doubts in a comment section. In the question, you have to find out a V naught and the power absorbed by the dependent source. Power absorbed by the dependent source. Now again you can see one point here very carefully. This is voltage controlled current source. So the magnitude here 2V naught is actually the current you have. This is actually a current. Okay. So 2V naught is flowing here. 25 ampere is flowing from there. So can you say directly how much current is going to enter in this branch? It is 2V0 plus 25. I just applied the KCL. Sum of current entering is equal to leaving. So how much current is flowing there? 2V0 plus 25. Okay. Now see, because of this current the polarity is plus minus. Because of this current the polarity is plus minus. Since the polarity is plus minus, I can say what is the V0? It is equal to minus 10 multiply the current. Current coming out at 2V0 plus 25. Now understand this scenario very carefully. Why I have put a minus sign here? Because the polarity which is given and the polarity because of current are both opposite. That's why. So V0 is equal to minus 20 V0 minus 250. So V0 comes out to be minus 250 by 21. So this is the voltage V0 that they are asking. It comes out to be minus 250 by 21. Let me check the calculation also. So I guess the calculation is correct. Minus 20 minus 250. Huh. So it comes out to be minus 250 by 21. Now they are asking find the power absorbed by the dependent source. So you have a dependent source here. You have a dependent source here. You have a current flowing through a dependent source which is 2V0. If you talk about the current of a dependent source, it is 2 times of V0. Understand this carefully. But what you don't have, the voltage across it. For a power you need a voltage. So let's suppose the voltage here is plus minus V. The voltage here is also plus minus V. So now I can apply the KVL. Okay, let's apply the KVL carefully. So if I apply the KVL, this is the direction of applying KVL. So I can say it is minus V plus 10 multiplied by 10, which is a total, sorry, my fault. Or you can say directly like this. No need to apply KVL. No need to apply KVL. You can also calculate the V directly. No need to apply KVL. You can also calculate the V directly. How? The voltage is across the series combination of two 10 ohm resistor. The voltage is across the series combination of two 10 ohm resistors. So can I say what is the voltage here, bacha? The voltage here is 10 plus 10. The total resistance multiplied by the current, which is 2V0 plus 25. है ना? So ये हो गया 20 multiply by 2 times of V0 minus 500 divided by 21 plus 25. Now we have to use the calculator to solve it. So I guess you can use the calculator. Okay, I'm not using a calculator right now, but yeah, you can use the calculator here easily, right? Let me bring a calculator. Okay, so I have a calculator. Now we can solve this easily. So we have 500 divided by 21. 500 divided by 21, 25 minus, it comes out to 1.1 multiplied by 20. So it comes out to be 23.8. So it comes out to be 23.8 volt. Okay, it comes out to be 23.8 volt. Now they are asking what is the power. The power is the current of a dependent source and a voltage across it. Current is 2 times of V0 multiplied by the voltage we have calculated 23.8, right? Now 2 times of V0, which is minus 250 divided by 21 multiplied by 23.8. Okay, let me calculate it. Multiply by 2 multiplied by 250 divided by 21. So it comes out to be 5 minus of 566.89. Now understand this point. the power now we have calculated here. First of all, you can, from the direction of current and the polarity, first of all see what kind of power you have calculated, absorbing power or delivering power. This is a current source, the current is going in this direction, leaving the positive terminal, so we are actually calculating a power delivered. So this power of minus 566.89 watt is a power delivered, but they are asking a power absorbed. So power absorbed is negative of a power delivered, so it comes out to be 566.89 watt. So this is going to be the answer. Calculation you can check it, but the important point is concept. So this is the particular answer we have. Okay. Now next, a very important question, and a very important point I am going to give you through this question. The question is, you need to find out voltage here. So I will advise everyone to pause the video and first of all calculate the answer, and then you can check whether you are right or not. Now here you can see that 2 ampere current is flowing. The same 2 ampere current is going to flow through here. So I can apply the KVL here. Let's apply the KVL here. Now when you are going to apply a KVL, I am starting from 2 ohm. The polarity is plus minus. So I can say it is plus 2 multiplied by 2. Then I have a 5 volt. Going further, I have a minus V. But the problem is now across a current source. I don't know the voltage across a current source. Across that current source, it can be 10 volt, it can be 100 volt, it can be 1000 volt, because the property of current source is that there can be any amount of voltage across it, the current remain constant. So if you have any voltage across a current source, the current remain constant, it means the voltage should be specified here, but the voltage is not given. But the voltage across a current source is not given, and you have to mention the voltage of a current source in a KVL, because KVL means the sum of a voltage drop across each element. Current source is also an element. So from here the point is, in this particular question, in this particular network, the KVL is not applicable. Now this is very important line, that KVL is not applicable. KVL is not applicable for the circuit, for the loop which contains current source of unknown voltage, If the voltage is given here, or if we need to find out a voltage across a current source, then we can apply the KVL. But in this case, I need to find out voltage this, and also the voltage across a current source is not given. For example, in the last question, in this question, the particular voltage V, it was across a current source, but we need to find out that voltage. So there we can apply the KVL. But here, since we need to find out a voltage across some another branch, and the voltage across a current source is not given, so the KVL is not applicable. And without KVL, you cannot solve this question. So the option is none of these. So the correct answer is none of these. So this question has been asked in your exam also, but apart from exam, you need to understand this very carefully. If the voltage across the current source is not given, you cannot apply the KVL. This is a limitation of KVL. Okay. Now it's a very simple question. We need to find out the current I4. Where is the I4? I4 is here. Very simple question. Across this branch, see this particular node. I4 is going in this direction, I0 and I1 is going. So I can say sum of current leaving, 5 plus 7 plus I4 are leaving, is equal to sum of current entering. No current is entering here. So I4 is minus 12, simple. Sum of current leaving, which is 5 plus 7, and no current is entering. So I4 comes out to be minus 12. Okay, understood? Yes or no? And guys, that particular point is very important. That KVL is not applicable for the loop which contain a current source of unknown voltage. Okay. Now try to solve this question in homework. This is your homework question. Example 13 is your homework question. Try to solve this question. You need to find out the voltage source E. Let me tell you the options, because the options are hidden. Let me tell you the option: minus 16 volt, 4 volt, minus 6 volt, and the last option 16 volt. Okay, 16 volt. Okay, so I will give you two questions in a homework. This is the first question and this is a second question. Again, let me give you the options here. The option is indeterminable, option B is 0, option C is 4 ampere, option D is 8 ampere. Okay, so you need to find out the current I in this circuit. The current I is here, the current I is here. You need to find out the current in this circuit. Okay, so these two are your homework. I will advise you to solve each of these questions, Also guys, you can join my Telegram channel. My Telegram channel link is given in a description. Also, this is the name of my Telegram channel, Electrical and Electronics by Ishan Mudgal. But I will advise you, you can see the link in my comment section also. So in the description of this particular video also, and join from that particular link. Okay, so bye guys, take care, see you on the next class with another important topic. I am hoping you are liking these videos. If you have any suggestions, you can give suggestion in a comment section also. Bye guys.